So here we are in part 4, which will be the last section of this CCNA switching lab that we've built. And now we're going to modify some spanning tree parameters. Because, as we talked about at the end of the last video, currently with the way spanning tree is that everything being sent from router 1 across these switches is going across our lowest numbered interface, is 1/9. But the objective said that it should be taking this path. So, what are we going to do to fix that? All right, well, step number 1 is we have to identify who is the root bridge in this particular case. Well, just by looking at this, hopefully you can answer that question. Only the root bridge would have all of his ports in the forwarding state. Well, that's actually not technically true, but in this particular case, that's the case. How do we verify that? Well, let's go on to Ether switch router 1. And we can do the show spanning-tree command. Now, if this was a real switch, you'd have to do show spanning-tree and then type a VLAN number. So let's go ahead and do that. Show spanning-tree for VLAN 4. And right here it says, we are the root of the spanning tree. And if we do that for VLAN 5, it'll be exactly the same. We are the root of the spanning tree. Now, when it comes to VLAN load balancing, the first thing you should look at is, if I move my root bridge around, could I possibly get what I want to get? Could I meet my objectives simply by moving the root bridge around? In this particular case, that's not going to help us. Because if I made the switch on the bottom, the root bridge, let's just say theoretically I did that. And let's say I did let's just say I did it for, now I think it said, the lab objectives here did not really specify which VLAN we're talking about. So let's say I made him the root bridge for everything. Well, all that would do is what we would see is that now all of his ports would go forwarding, because the root bridge, every port is forwarding as a designated port. And then the switch on the top, he would end up saying, well, I'm going to go ahead and go forwarding on my lowest numbered port, and I'm going to go blocking on this port. I'm not going to go into the details of why. If you're not sure of how that happens, please look at my CCNA video series on routing and switching, where I go into gory details on spanning tree. So moving the root bridge around, not going to help us. So might as well get rid of that. Let's go back to where we were. All right, so ultimately, here's what we need to do. We need to somehow trick Ether switch router 2. We need to make him believe that this interface here should be his root port. We want him to select this as the root port so that he'll go forwarding. So how do we make him believe that? Well, we actually have 2 ways that we can do it. Number 1, remember that spanning tree ultimately relies on cost to figure out the best path through a network. So one thing we could do is we could go onto his interface and tell him, hey, the spanning tree cost of this interface is less than the spanning tree cost of 1/9. That's one thing we could do. Alternatively, we could leave the cost alone, because right now they're exactly identical. Because when the cost is identical, what ultimately ended up causing this scenario was the port priority. The port priority. You see, in this particular case, when BPDUs came downstream this way, both those BPDUs had the same bridge ID because they both came from the same bridge. They both had the same cost, which was 0 because they were coming from the root bridge. The only thing that was different about them was that the port IDs were different. Now remember, port ID in spanning tree is a 2-part field. You have a port priority and a port ID, a port identifier. Well, by default, the port priority is the same. It doesn't matter. It's always the same. So if the port priority is the same, the only thing that made these unique were the port numbers. And 1/9 as a lower number than 1/15 was preferred. Now you can't change the port number, but you can change the port priority. So let's do both. Let's go ahead and modify the cost, and then we'll set it back to default, and then we'll modify the port priority. So if I want to modify the cost, I'm going to want to modify the cost on this port right here, 1/15 on Ether switch 2. All right, so let's get out of Ether switch 1. Go over here to Ether switch 2. Let's go into interface fast Ethernet 1/15, spanning dash tree, VLAN 4, and now we're going to want to say cost. And, well, what's the cost right now? Well, you should know for the CCNA, the cost of a fast Ethernet link is always 19. If you're using regular 802.1d, that's the default port cost. So let's do spanning dash tree, VLAN 4, cost, how about 18? And let's do that same thing for VLAN 5 as well. And now when we do show spanning tree for VLAN 4, remember, who are we on right now? We're on the bottom switch right here. And what did it look like previously? Previously, 1/15 was in the blocking state. But now what we've done is we've said, okay, your cost to get to the root bridge on 1/9 is 19 because it's fast Ethernet, but your cost to get it to the root bridge over here is 18. We lowered it. So now ultimately we should see these two swap. We should see 1/9 go into the blocking state, and we should see 1/15 go into the forwarding state. And there we go. 1/9 for VLAN 4 is blocking, 1/15 for VLAN 4 is forwarding. And we'll see the exact same output for VLAN 5 because we modified the cost for VLAN 5 as well. 1/9 is blocking, 1/15 is forwarding. So if I scroll down here, you'll see that on 1/9 we didn't do anything. We left it to its defaults. But on the interface going upstream to the root bridge, we modified the cost on 1/15. So that was one way that you could accomplish this objective. The other way was to leave cost alone. So let's go ahead and take this out. The other way was to go to the upstream switch that's sending you the BPDUs and modify his port priority. So let's go to Ether switch 1, interface fast Ethernet 0/. Actually, before we go there, show spanning dash tree VLAN 4. And we can see here that they both have the exact same port priority of 128. That's our default port priority. So now what we're going to do is we're going to lower his port priority to 127, which will make the guy downstream from him, which is Ether switch 2, prefer fast Ethernet 1/15. Spanning dash tree, and I'll just do it for everything. I'm not going to specify any particular VLAN, although I could. Port priority 127. But we have to do it in increments of 8, so we'll do 120. So now what's happening is we're back to this, where we on the bottom switch we have 1919, but the BPUs are coming down from Ether switch 1. This one has a port priority of 128. This one has a port priority of 127. And remember, in spanning tree, lower is always better. And so now that will cause Ether switch 2 to swap out these numbers, and now this will go blocking, and this will go forwarding. So let's verify that. Let's go back to Ether switch 2 and make sure that 1/15 is now in the forwarding stage. And there we can see the lower number port is now blocking, the higher number port is now forwarding. And that concludes this CCNA level switching lab.